Hello, everybody. Welcome to this first inaugural edition of the AutoCall Fire Detection Academy webcast series. This is a new series of courses that's designed to deepen your understanding of some of the key features and technologies that we have within the AutoCall product line, and basically to deliver a deeper set of knowledge and understanding than what you get out of the normal launch webcasts that we do. When we do the launch webcast series, the idea is to raise awareness of the product and to help you understand the features and benefits of the applications. But what we recognize is that once you get into the product and start really selling it, other questions arise. Can I do this? Can I do that? What applications can I really do with the product, and when I really get into the trenches and apply it? And the idea of this session is to serve as a bridge between the launch presentations that are let's say 20,000 foot level, and coming to a full-blown multi-day class in the Westminster or facility or your local training facility. So that's the plan for the program here, and we're going to kick this off today with a discussion of TrueAlert ES addressable notification technology. My name is Pete Ryan. I'm on the marketing team for global fire detection products at Johnson Controls, based out of Westminster, Massachusetts. And today, hosting the content is going to be Brian Shifley and Dave Govin from our training and development team. Dan and I always want to call him Dan. It's Dave. Sorry. Dan Govin's your brother. Dave and Brian are two very highly experienced members of our training team. They have a lot of years of experience with our product lines and also in the classroom. So I'm really excited that we have two such expert folks here available to present this material, but also to answer your questions. And really do feel free to bring any questions you have about the technology, integration, or how this all fits together, because you've got two really excellent experienced minds here with you today. A couple of housekeeping things before we get started. Everybody in the session is on mute. The microphones are live, so if you unmute yourself and you talk, you will be heard by everybody, and we'll have you on mute to eliminate the background noise. The session is also being recorded, so if you have any concerns about privacy or don't want to be recorded during the session, which is going to be published later on, I'd recommend that you drop off now. Also, in terms of questions, what we're going to do is hold the questions to the end of the session, where we'll open up. We should have a good 15 to 20 minutes for Q&A. You can ask questions verbally at that point, or you can type questions at any time via the chat interface here on Teams. We'll all see those questions that you're putting in, all the comments and so forth, and we will go through those at the end, and we'll answer as many of them as we get to. So with that, I hope you enjoy the session. And I encourage you to ask questions and to get as involved as you can on this, because this is a really great opportunity to expand your knowledge about this feature, which is something only we have in our product line, and is a real differentiator in terms of design, in terms of installation, in terms of customer maintenance, and in terms of the features that you can really offer your customer base. So with that, I'll pass it over to Brian.
Okay, thank you, Peter. And welcome, everybody. As Peter indicated, we're here to talk about TrueAlert ES. And this is sort of a bridge, like Peter said, from when you are coming on boarding and you see that lunch and learn material from your sales rep to the dealer. And until you get to training, there's a whole lot more in the middle. And I hope that we can enlighten you today on just some more of these features of TrueAlert ES and why it's superior. So without further ado, I'm going to move on here, and we're going to start here and take a look at something. Whereas we look at the TrueAlert ES as a total system feature, and what it does for us is it takes conventional notification and it transformed it into addressable notification. So each individual unit is addressable. It gives us flexibility to put it out there in the systems with T-tapping and flexible wiring design. And when we do testing, which we'll talk a lot more about shortly, it's hands-free, and we can push a button essentially and test all of our notification appliances and then be produced a report. So some really great features that are going to help enhance your recurring revenue stream down the line of very, very important to the TrueAlert ES product. So when you have addressable notification, you have easier troubleshooting and system expansion. So some more on those technologies soon. And so really what this is it's a family of intelligent addressable notification appliances, both a xenon strobe and an LED appliance section as well. So let's start off by, where did this start? So to me and to everyone else here, this started at conventional notification because we took that technology and then we advanced from it. So to see where we went, we have to see what we were faced with. So with conventional notification, we have an ACK circuit that has a 10K resistor end of line, typical. And in this case, this circuit reached its maximum potential, meaning we got to the 3-volt drop with 13 devices using 30 candela devices. Okay, so that's typical. Number 12s, maybe a dozen devices or maybe 10, depending on the situation, and then you're done. And then now you need a new NAC circuit, which in this case was NAC 2, which we haven't yet to start. So where's the competitive advantage in this design? Many manufacturers use the same thing. So when you look back at the AutoCall product line that supports the conventional notification, this is our design. So the real competitive advantage comes with TrueAlert ES. And that means we have taken a conventional circuit and we redesigned it, and it became now an SLC. So this SLC doesn't work from just 24 volts, but it starts at 29. So 29 volts from the terminals at the board. And we can support a 6-volt drop, which is double from our conventional design. So with that, 29 volts and a 3 amp availability of power. So I did the same design calculations here. I put the same 13 devices, only with addressable notification in this design tool. And you'll notice down here at the bottom, under the word design pass in blue, you'll see it says 0.721 amps. Many of you may be familiar with this tool. So that tells me that these 13 devices are only consuming 0.721 amps, 721 mils, which is roughly half of what it was on the other page. So we've got half of the power consumption at the same amount of devices, and we still have plenty of remaining capacity to continue on. So this is the brilliance of addressable notification. With a greater voltage range, and we get a 6-volt drop versus 3, it really gives us the ability to do many things, including doing something called T-tapping. So let's go to the next slide here. And when we look at T-tapping, in this example, it shows 3 different areas. So we have a main line coming from a panel, and then we have a T-tap to an area C, and we have a T-tap to an area B, which is common. So what does that look like if we were to go into the TrueNAC circuit design tool? Well, it looks like this. As an example, from our IDNAC circuit, which is a 4007 ES panel, which is what I did this on, we have a T-tap with isolators going to different branches, and then separate T-taps going to different areas of the building. So as you can see, there are several devices here, and it continues off the screen quite a ways, but it only uses just over half an amp of power consumption. So it's very, very power efficient. So if we go from Class B and we move to a Class A, we accomplish this by having what's called a dual Class A isolator card. So again, we have 2 areas of the building using Class A. And when we go into the design tool, it looks like this. So we have a circuit with an isolator, which is called a DC AI. And then we have our devices. And at the end, there's a DC Class A return. And so doing an example on a 4007, this is what it looks like when you're using that tool. So the voltage drop calculator, which is what you have today, you can get on the AutoCall website, does these calculations. We show all the different devices, the device part numbers, their voltage, and their current draw for each device. And along with the number gauge of wire, along with the different spacing in between. So that's today's tool. So coming soon is a new tool. And this new tool is a new IDNAC point-to-point circuit designer. And it looks like this. So this one is spreadsheet based. It's not yet available to you, but it is coming soon. It's in quality assurance at the moment. And so this is just an example of a point-to-point circuit design using 3 devices. And so this is one of those things that's coming soon. So what happens when we get to a circuit that doesn't have enough power? We lose our 6 volts. or we get to our 3 amp limit. What happens? Well, we add what's called a 4009 IDNAC signal repeater. The signal repeater allows up to 5 parallel runs. So each one of these units gives you a fresh 29 volts and a fresh 3 amps. So one of the questions is it Class B or Class A? Does it do both? Does it do one or the other? Well, it does both. Biting a card inside the unit, we can get Class A. So again, each one of these repeaters enables us to have a new set of 29 volts and a fresh 3 amps on a circuit that's isolated from its circuit that's feeding it out to the area that needs to be serviced. So each one of these repeaters does take up an address on the IDNAC circuit. So it is one of those that we put in the programmer. But they have a specific use. So once we need to continue on, fresh 29 volts, fresh 3 amps, and keep going. So who benefits from this? Well, there are a lot of benefits between the engineers, the building owners, and the contractors. The one that matters the most to a building owner might be that self-testing capability that we'll talk about soon. Maybe he likes the fact that that can be done at night, overnight, or on the weekends when no one's there without disrupting anything. So that's going to cost him less money. Less labor to be there at night, less labor to be there in the weekends. So that could roll into a lower recurring revenue cost for him on his inspections. So why does it matter to an engineer? Well, the engineer is going to design the system, and that gives our TrueAlert ES gives them the ability to do greater flexibility when you're dealing with the wiring, right? So we can drop a circuit that has multiple T-taps to service certain areas, and the engineer can strategically place those T-taps in certain places and really get a really good design that is quite flexible and easy. And so for the contractor, where does it really matter to them? Well, wire is money. So if they're using number 12s or number 14s, that's more expensive than if they're using a number 16, because the tool will tell you what type of wiring that you can use in your building, in the design. So the wire also is unshielded, which is another cost savings. So again, that flexible wiring architecture enables someone to, sorry, I'm just going to prompt here. That flexible wiring architect gives that engineer and the contractor the ability to actually place those T-taps in strategic places. So now when we move to the architecture, when you take a look at a system that has conventional notification, such as the one on the left here, you see the 4009, which are the conventional signal modules. And they're servicing, there are 3 of those along with a 4100. And so there are 98 appliances across those 4 pieces of equipment, which is typical. But what does that do for us when we go to TrueAlert ES? So we go from number 14s with 13 NACs over to the TrueAlert ES, which is 18 gauge using T-tapping. And we can do that with only 3 signaling line circuits. So 3 SLCs, we can do T-tapping. We use a little over 1,000 meters of wire versus 1,300 meters of wire, almost 1,400 with the conventional. So again, so you can see the improvement and the layout of the building and the use of the wiring. So what does this really mean to us? Well, it brought us using T-taps and having lower current draws and those higher voltages from that 19 spec to 29, we get a 50% cost reduction in wiring material. That's significant. We also get 26% less NAC wiring, half as many AC connections and batteries because we don't need those other equipment. And then there are 77% fewer NAC circuits themselves. So taking a conventional circuit, converting it to a SLC, and then adding addressable devices is the way to go. It really does bring you the best bang for the buck, so to speak. So what about testing? Testing is important, and that's one of the major features of our systems. We have to do testing. Great revenue generator. So when we do conventional appliances, as you all know, we have to test the whole circuit at the same time. So sometimes that's a floor, Sometimes that's an area. Sometimes maybe that's 2 floors. But we have to do them all at the same time. And so if it's occupied and they have to stay on, it really does make it so that it's a tough pill to swallow for a lot of customers, which costs them money because now you need to do it at night or on the weekends. So what we've done is we've created self-tests. So this is a patented test capability. So the TrueAlert ES appliances, they have built-in light and sound sensors. So if that strobe turns on, the system knows it. If that audible activates, the system knows it. It's given feedback from the device of itself back to the CPU, and all that information is stored. So testing these devices can be done in 2 ways. They can be done automatically, or they can be scheduled. So the bottom line is a full notification appliance system, TrueAlert ES, can be tested in seconds. So whether you program a button on the front of the panel, or we schedule it to take place using our custom cause and effect programming. So it can take place weekly, monthly, bi-monthly, biannually, annually, etc. But once that test takes place, that report is now sitting there waiting for the user to pull it off on the panel. So if that report comes off, say it's on a 4007, it can be done by someone using a USB stick. It's very, very simple to do. So another form of testing is called manual self-test. So that's where the user manually sets the circuit to the self-test mode, and then a technician or an inspector can walk around using a magnet and go to each one individually. Go to the device, use the magnet, and then again, you pull that testing history off once you're done. And so if they don't want all of the horns and strobes to go just for a second or two, then they're just done individually. So that eliminates disruption. So we talk about TrueAlert ES, that self-test, how does it work? Well, again, like we mentioned before, each device contains a built-in sensor to measure sound and light. Did it work? Did it not? If it worked, great. It goes into the log. If it didn't work, it goes into the log, certainly. But it also creates a trouble on the panel that something's wrong. And somebody would be able to go and investigate that. That would be reported back to the central station or to whatever the proprietary reporting means are. So these appliances, they test themselves. And how does it do that? What's the method? Well, the horn pulses for a second and the device flashes the strobe for a second. So sometimes the strobe will flash more than once. Could flash up to 3 times in a second. But then the appliance sends that device status back to the panel, generating that report we talked about. So when doing something manually, this is how that looks. So with one device, we go to the device with a magnet. So again, standing there at the device, the strobe will flash for a second, the horn will pulse for a second, and then there's a red LED that's inside the xenon strobe housing. And that turns on to indicate that the appliance is being tested. So there's a visual indicator to the inspector that this is taking place. And once the test is finished, that light goes off. Furthermore, as the system just operates in a daily way, those LEDs blink every time the device is pulled by the CPU. And that's also an LED that you can turn off in programming. So if you're in sort of an NBC Suites type of a situation where it gets dark at night and you can see all the devices on all the floors and it's dark, you'd be able to see all those lights flash. I've witnessed it. It's kind of neat. So there's an option to turn those off so that they're not, people aren't drawn to it. So another way to do testing is by scheduled self-test. This is where a technician at setup would be able to put cause and effect programming into the panel, and that would execute a scheduled self-test, whatever that interval is that we had talked about before. And that can be changed at will by someone who can do programming. So once that's set up, now you have a customer who has the ability to not need someone to walk around doing an audible and visual verification. They would just need to do a placement verification walk around, which is a much different test and doesn't take very much time at all and doesn't involve anyone having to do anything except walk around. So it's nobody's getting interrupted by doing anything, by having a noise or a sound. So when we talk about this self-testing thing, a lot of people say, well, who says that we can do this? A lot of HJs are not really, maybe they don't believe in it, they don't understand it. It happens. We've seen it all over the world, right? Well, for here in the U.S., NFPA 72 authorizes it for us. And so Section 14.2 regulates automated testing. It says that there are some rules that you have to follow if you do that, and we certainly do follow those. And that's our marketing claim. But how do we know that that's right? How do people don't know we're just spinning a fairy tale? Well, it's true. And how that we know that is we have verification from UL. So anyone can go to the UL website and look this up. This is a verification mark from Underwriters Laboratories to us detailing that they've tested our self-test feature and that it meets the marketing and the branding claims. So this effective date on this was October 1st of 2019. It's good through the end of September, which of course I'm sure it will renew. So the self-test feature detects the functional output of audible and visible appliances. That's the claim, and that's what's been verified by UL. And this is their stamp and their stamp number for us. So we have a way to go back to a customer and they say, well, is that even approved? Who approves it? Well, UL verified it. So NFPA code says it's okay to do it. And the verification piece from UL says that, yeah, it really does work. And so the second page here is, what is this verified operation applicable to? Well, it's to all of our ES panels and our 49 and our 59 series addressable notification appliances. So the verification method that they used was the operation of the self-test feature was assessed per the product's operating manuals. To confirm that, self-test initiates without operator interaction. The self-test routine attempts to sound an audible alarm and flash a visible alarm. And the self-test routine records the results of aforementioned testing. So this has been verified by UL. So this is an excellent piece of paper to take with you when you're talking to your building owners and your specifying engineers and your HJs, for that matter. So moving from this onto the TrueAlert ES speakers. So TrueAlert ES speakers are ceiling mounts and wall mounts. And they are a complete family of these types of devices. So like the earlier AVs, these devices also have a unique address. So individual unit supervision, individual control, we can turn each one on and off at will. We can do them in groups and we can do them individually. And that's something we're going to talk about in a couple minutes. So if anything breaks, if anything stops, a wire is cut, if anything malfunctions, the device either reports the trouble or the system sees that the device is missing and raises the alarm. In this case, being a trouble that is missing. So these speakers also have self-test capability. They have the speaker, they have the sound pressure, the sound meter, and the light indicator. And like the earlier devices we talked about, we can also do T-tapping, not just with the IDNAC circuit that feeds it power and communications, but also on the audio wiring that comes from the amplifiers now. So that's a new thing, T-tapped audio. So the speaker itself actually supervises whether or not the amplifier is actually there and talking to it in the background. So it's pretty neat. So what about intelligibility? Well, this is really important. So when we look at this chart, we look at the low end, which is from 90 to 200 hertz, its bass. And we see on the far end, we see the harmonic, the brilliant side. And so our TrueAlert ES extended range covers a majority of that frequency, all the way down and all the way up. And when you take a look at and you match it up against a typical high-end home entertainment system, there's not much. The end of the ranges are taken off, but there's really not much in quality that's missing. And why is that important? Well, better frequency range means better sound. We get quality and clarity. And that also gives us the ability to have a dual use system. So our fire alarm speakers that are in a building can also be for background music. They can also be for announcements from a central location in a building or from a phone system interface. So anything that's used as a PA, we can do on our fire alarm speakers as well. So again, so emergency and non-emergency announcements, background music. And background music, when it's playing, the device is still supervised, as is all of the wiring connected to it. So unlike earlier versions of conventional audio, whereas whenever anything was playing, the wiring wasn't supervised. Well, now this does. This is supervised all the time. So you don't need a separate system. And going to your customer, there's a competitive advantage, because if you can use one system versus 3, you can save your customer money as you're doing that design. So when we do speakers, they have xenon strobes. And xenon strobes support 15 to 185 candela. They also have a line of lenses that are available to you if they're needed into the specification. So on the bottom here of the slide, we added in this chart that shows when you put the colored lens on, what does it derate the strobe intensity to? So as an example, the first one with a 15 candela appliance and using a red lens, that reduces it to 3 candela. In fact, that's what we use in our training classroom so that we can reduce the strain of a technician standing in front of the panel. We use the red lens. So when we talk about NAC circuits, one of the things that we do is we have virtual circuits. So each of these individual appliances has an address, and these addresses can be grouped together to form virtual notification zones. And each ES CPU supports 255 TrueAlert VNAC zones. So think of it, in this case right here, if we just had 4 floors, where you're going to do floor above and floor below, we would use 6 VNACs to cover this, from the parking, the basement, all the way to the 4th floor. So 6 out of that 255. And now, depending on which type of panel it is and which power supply we're using, is the number of VNACs that come with each power supply, which is shown here. So in this case, a TrueAlert ES addressable speaker being powered from an ESPS power supply, one of the SLCs, and then fed audio from an amplifier. Each ESPS carries the ability to support 56 VNACs, and that's the limit. So from those VNACs, in this example, there's an east side of the building, which we would call VNAC 1. The west side of the building could be VNAC 2, and then the whole first floor would be VNAC 3. So if you wanted to have the east side of the building alarm playing a message versus the west side, or altogether general evacuation, that can be done. So each power supply supports 56 VNACs, and a CPU supports up to 255. So what happens if you get to the limit of your 255? Well, there's a method to do that, and I'm going to show you that in just a few minutes. So when we deal with speakers, something that's new to us is we use T-tap speakers. T-tap circuits and unshielded wiring, and no longer do we need end-of-line resistors. So an end-of-line resistor that's on a NAC circuit on an amplifier is no longer required, because the speaker itself is now supervising the sound and the connection to that amplifier. So an ID NAC circuit feeds the speaker, and the audio circuit feeds the speaker, and that speaker is intelligent. It communicates with 2 ways. It's monitoring that amplifier as well as communicating with the CPU to say, yes, I'm here and I don't have a problem. So again, no shields on the wiring, which is a significant thing, because everybody in the business on this call probably knows shields and grounds are just awful. So a closer look at these speakers. Take off the cover. This is what it looks like underneath. There's some heavy plastic, and then there's a speaker right in the middle. And then on the far right, you're going to see that there are a number of components that make for the appliance settings of how this device operates. And so what those things are is this first one right here, which is the magnetic test point. That's where that little magnet's going to go, and you're going to put it into test mode. It's in a different spot here on the speaker versus in the AV. The next piece we have is that 25 or 70 volt selector switch. So depending on which amplifiers you're using for whichever situation, the length of cable, 25 or 70, you just make that adjustment here. The audio circuit power taps. In the past, we used to have to take off little wires and plugs and move them over and plug them back in electrically and really just touch those conductors. Well, we don't have to do that anymore. Now we use a switch, and that switch is supervised. So if it's in the quarter watt position and it's not in the quarter watt position at the panel, we'll get in trouble. So if none of the settings match, we get an indication. It's very important. And then we have the device address dip switch. Each one of these speakers has its own unique address, and it's depicted here. So when we look at the strobe settings, the strobe has a little device that you would move from the FACP position to the hard-coded position from 15, in this case, 15 to 110 candela. Now, if the program is set for FACP and then this is moved to say to 30 because they want it to be 30, well, then there'll be a mismatch between the programmer and the piece of hardware. So the programmer would have to be adjusted. Otherwise, it can remain in the FACP position, and then the strobe can be adjusted straight from the ES panel programmer without having to do this. So this is made for HJs that require you to walk up to a device and be able to see and tell what its candela rating is without having to go do a report, which is something we can do with our TrueAlert ES system. We can do a TrueAlert report, and we would be able to see what all the candela ratings are set to from the program. So if that's not satisfactory, then there's always this method by actually physically moving that. So moving from those speakers, we look to the next piece, which is our low frequency notification, which means the 520 hertz requirement. So what about that? So where did that come from? So the 520 hertz requirement came about because of studies that were done between 98 and 2001, because different segments of the population, they woke to different sounds, and it was very widely varied. So a lot of people, some woke up, some didn't. So 48% of fatal fires in residential buildings happened in the overnight hours between 11 and 7 a.m. and 35% of these victims were sleeping. So continuing on, Gallaudet University research, the Institute estimates that 6.8 million people will not likely hear a smoke alarm, regardless if they're awake or they're not. And 43.6 million will not necessarily hear it all the time due to having some kind of a severe hearing impairment or being functionally deaf. And then there are the kids. So it's an unrelated study that showed that conventional smoke alarm effectiveness and parental tone of voice, only 58% of children between the ages of 6 and 12 were awakened by the tone. And 22% of the US population is under 15 years old. So there's a huge impact here for trying to wake people up in the middle of the night. They're varying states and varying ages. So the NFPA Commission came through and they did a study in Australia, and they found that the 520 hertz square wave at the time in a T3 pattern was the single most effective way to wake people up. So if the sound was at 75 decibels, 92% of the study participants woke up, and if it was at 95, that woke up everyone. So that was a significant breakthrough in a study to show that something that we could change would save lives. And save lives it did. So NFPA introduced that back in the 2010 edition. And so in the NFPA 2019 edition of NFPA 72, section 18.4.6 shows all the sleeping area requirements. Bottom line, the waveform will have a fundamental frequency of 520 plus or minus 10%. And for those that have sleeping rooms and guest rooms and those with mild to severe hearing loss. So they have to have those sounders. So it's a very, very important piece of gear for us to sell, and a huge effort in us to be saving lives. So where do we require these? Well, mostly it's sleeping areas, hotels and motels, apartments, condos, colleges, etc., retirement and assisted living facilities. And where they really don't have them required is like lobbies, hallways, meeting rooms, and so on. But there is some discussion that we learned in the last session about adding them into living rooms in homes. Well, living rooms, because people do sleep in those rooms and not necessarily are in their bedrooms. So that's something else that's I'm sure will be talked about in the future. So what did we do? So to answer that 520 hertz requirement, the first thing we did was we added the 520 hertz tone into a standard library for the 4100ES audio system, which is completely backwards compatible with all the 4100Us and 4100ES audio systems. So how do we upgrade to that new chipset? Well, chipset 42 is downloaded from the AutoCall website, which today that's the one that's up there, and that tone is included in the audio package. So easily, one, if that wasn't in there, could be retrofitted. Then we go from the audio systems, we go to our multi-tone horn. This is also an addressable ID NAC device that has wall mount, and it has a 520 hertz multi-tone availability, and it comes in both addressable and conventional devices. There are 7 selectable tones and 6 different selectable candela settings. It does have that UL approved 520 hertz square wave. So the beauty of this device is that it can be commanded to play 520 hertz and then a T4 for a CO sensor. And then it could be commanded for a T3 for a single station smoke alarm in the room, and then go back to the CO or whatever, because these are addressable and they will follow the commands that are given to them by the CPU what to play. We also have a ceiling mount sounder base that has 520 hertz. So this example shows one of those devices that has a CO sensor. So this is something maybe would be in a room that may have either a gas fireplace or a wood stove. So if we're retrofitting, yeah, the easy one-for-one with legacy devices. So if you're doing a system change, you can reuse the existing sensors and the wiring, you just would need to change the base. Now this device itself, this sounder base, the 9773, as you can see, has a built-in speaker, so the tone generator is inside the unit itself to ensure that we get that perfect 520 hertz square wave sound.
Yeah, just if I could jump in there for a second, Brian.
Sure.
This is Peter again. So if you go back to the earlier slide, one of the key things on here, though, and I just want to make sure that we stress this enough, is that the power availability is something that you really need to take a look at. When you work off of the piezos, especially on an existing facility. Like, for example, let's say you have a hotel and you did the hotel or you did a dorm, and you put in regular appliances or regular sounder bases, and then the AHJ comes back and says, okay, now we've adopted this 520 hertz. We're gonna do this now. You can go use these appliances. You can take out the old base, put in the new sounder base, use the wiring. You could take out the old appliances. The whole idea, like Brian said here, is that these are retrofittable, and to get you to the 520 hertz tone with the least amount of pain. But you do have to make sure that you look at power. Because these require a speaker, they eat more power, and they are more expensive, bluntly, than a piezo-based device. So if you have an existing facility and you're going to pop out all the old bases and put in the new bases, you have to make sure you check your power, because it's not one for one. You may need to add supplies, you may need to add batteries. It's just something to really carefully take a look at. And that's the whole key with the sleeping arrangements. Really, these are designed for places where there is unattended sleeping. So if you look at a hotel, if you look at an assisted living facility, an apartment, you're in there and you're sleeping and you don't have anyone attending you. If you're in a correctional facility or a hospital, that's why they're not required there. And that's why they're also not required in the public areas. So the hotel, you want to make sure you put them where you have to put them, which would be in the sleeping rooms, and not broad brush them everywhere in the hotel, because if you do, it's going to cost a lot of extra money and a lot of extra power.
Very good. Very well said, Peter. Thank you very much. So when we're talking our TrueAlert ES, we talked about VNACs, 255 VNACs, but 56 per power supply. Let's say we have a 4007 ES and we're doing a small hotel, and which will give us 56 VNACs with that power supply. So how do we do the programming? Well, first off, we have to take a look at what the concepts are. We can individually control these devices. So we can do them in groups and we can do them individually. So here's how this works. So we have a suite alarm, a smoke or a CO in one apartment, and the speaker audio plays a message or a horn plays a separate tone. So as an example, if this was a room that had a fireplace in it with a CO sensor, that CO sensor activates, we're going to get that T4 tone. And then if for some reason in that same apartment, somebody burnt popcorn, well, then it would go to T3 automatically. And then once that T3 condition is cleared, if that carbon monoxide level was still above the threshold, it would go back and refer back to T4. And so that's an important part of controlling appliances individually. So in an apartment, in a group, in a floor. So here's that single apartment, and how is that apartment wired when we're looking at the floor? So just to get back to the connection criteria, so we're looking at a single IDNet loop and an IDNAC loop using T-tabs and getting all four on a floor. So the 4007 could be used very, very well in this situation, depending on the power requirements and the candelas and so on and so forth. But we have these multi-tone horns. They're programmed to use a 520 hertz. And so if we were to get that indication in the bedroom, then it would be on 520. So if you had another apartment that was having a separate issue, well, it would play its tone, which is either T4 or T3, etc. If it was multi-tones or whatever the speaker circuit in there, it would play that. So individually dealing with it. And then lastly, if we are looking at it as the entire complex, 24 apartments across 4 floors, well, there are many speakers. So we've got speakers in the rooms, multiple speakers in each apartment, potentially, floor, hallway, common areas, and so on. So when we talk about programming considerations, we're dealing with speakers, virtual NACs, audio channels, evac alert.
But to get it out the door, you got to take the top off, and it just screws.
Okay,
The only new buyer, he's going to take a look.
Sorry about that, guys. Okay, so programming considerations, speakers, virtual NACs, and audio channels. Now we have to deal with alert, evac, even background music, potentially. This can be a programming nightmare, but what do? Well, we take this and we do this. We use what's called a programming wizard. So when the ES panel programmer, there are capabilities in here that enables the technician to use a programming wizard to be able to make the system work the way it's supposed to based on your custom design. So we've tried to do this as easy as possible, and we do teach this in our classes that are held in one of our 5 training centers, or if we're coming to you in our new VILT program. And then we go beyond the speakers, the 49 series speakers with the Xenons. Then we move into the next brand of the next level of devices, which is the 5900 LED series of devices. So this LED series has a suite of horns and strobes, strobe onlys or horn onlys. So they have the same characteristics of self-test, light sensor, sound sensor, ability to T-tap, and so on and so forth. So if you have a customer that's looking for a horn application that needs to have a smaller footprint device, and it has a single gang box requirement, so that's a little bit less expensive to the electrical contractor to install those as well, then this is the device you're looking for, red and white, of course, as you see. Now, how big is it? Well, it's compact. It's about the size of a cell phone. Many of you have seen these already. If we look at the different candela settings and the different switch packages that are on here, has the same characteristics as those 49 series devices where we can pick the tone if it's a horn, what way it's going to play, its address, as well as the strobe output, setting that using the switch on the side, FACP, or in this case, as you see here, we have 110, 135, and 185 candela. So choosing any of those three for this particular device that has 110 to 185 only consumes 125 milliamps. So that's a significant cost savings when you're looking at 185 candelas applications. Of course, it's not the whole building, but it could be certain areas of the building based on the code requirements that you have to support. And so what do? Well, you can choose the right devices. You can choose one that's red, one that's white, the different covers. The 49 series has 3 pieces to it. It has a cover, it has a base, and an appliance. These LED devices have 2 pieces. They have the appliance itself and the cover that goes with it. So what about putting them onto the same circuits? Do they play nice? Yes, they do. So first, before we get to the play nice, let's look at the LED versus xenon power consumption. So 185 candela is 125 milliamps, and 185 milliamps on an AV is 330. So a significant savings in power consumption for strategic use. So, but there is flexibility, which is important to us because you can utilize 59 series LEDs along with the xenon strobes and put them on the same circuit. Everybody plays nice. So you have 185 candela or a higher power consumption candela requirement. You can sell those small ones to do the job, and you can leave the xenons being the most popular units that are in most of the common areas and so on. So everything plays nice. So it's all about power consumption. We have a lot more power with TrueAlert ES, and we have a lot more efficiency with these two. So combination of using the two, you can really get the job done at the lowest cost possible. So one of the characteristics of this LED appliance is that it have a 20 millisecond light pulse duration with a maximum duty cycle of 40%. And we do comply with that. In fact, we were the first manufacturer to comply with that order from NFPA 72. So it's a great tool, a great device, and TrueAlert ES really is an amazing feature set of a brilliant product line. And now I would be happy to take any questions that anybody has for the team. Any questions or comments? You just need to unmute your microphone in order to.
Yeah, Brian, I just noticed looking at the chat log here, there's some running dialogue. I know Dave has answered some of these questions about the addressing and so forth. Dave, I don't know if you want to pop on and do any clarification here.
Sure, let me bring up that conversation history here.
Yeah, sure.
Oh, Dave, I'll mute mine again. Okay.
Yeah.
Sorry, hang on. Wait a minute. Okay.
Oh. Dominic, did you get most of your questions answered?
You gotta unmute your speaker.
Oh, shit. Dominic, are you there? Oh, he responded in a text. He mustn't have a microphone.
Okay, yeah, now August, I know, doesn't have a microphone. He was asking, are there 59V series speaker strobes, and do they also fit in a single gang box?
Yes. Well, not speaker strobes. Horn strobes, yes.
That's right. They're horn strobe line only, not speaker. Tell them that the speaker strobe line is xenon base strobe line.
Yeah. The slim series for horn strobe only, not speaker strobe. Hopefully August can hear me.
Okay.
Thanks.
Yeah,
Okay.
just looking on some of those. Yeah, that was it for August. All right, and just looking through the lines here, see if there are any other questions that we didn't answer. And it doesn't look like it. Anyone else, if you have a question that you want to ask verbally, just go ahead and unmute yourself. We just had a text one come in from Danny. It says, when using aux input or background music, can you select specific zones to broadcast? If so, do you have examples of the custom control equations?
I can't directly answer that. That I would refer to a tech support specialist. We don't run that particular practice exercise in our classes because we don't have the equipment to really answer those questions. But we can defer to tech support and get back to them.
Yeah, that's a great question. I think we should follow that up. I think everybody would be interested in that answer. I know we can direct the emergency paging to what specific zones, but I've never looked into directing the actual background music. So that's a really good question. Any other questions from anyone? Got about 9 minutes left here. If we want to have a discussion, comments, feedback. No, quiet bunch today. Okay, then. So I guess, Brian, do you want to have any last words or do we want to wrap it up?
Sure. I would like to thank everybody for coming by and experiencing this TrueAlert ES with us. We look forward to doing some more virtual roadshows topics over the course of the next several weeks. So we'll be sending out invitations for those. Hopefully next week, we're going to be using a different method for you to register, which we'll send out an email, hopefully to get you to the website to click on a register icon link. But we're working on the LMS portion at the moment. So it's more important to get the information out to you versus having to wait for all this stuff to catch up to us. So that's why I sent one out from my personal email to everybody. And thank you all for, some of you had questions about the sessions earlier that I answered. So thank you for those. That was really good of you to ask. And so I look forward to seeing you probably next week. The next session we're going to be doing is on the ESPS power supply. And I believe we're doing that next Friday. So stay tuned at the beginning of next week to be able to see those invitations. Thank you, Peter.
Great. Thank you, Brian. Yeah, and thanks to you and to Dave for such a good and informative session. It's really great to get into the details and how the power calculations and the actual applications are going. We will, as I mentioned at the beginning, be publishing the recording of this session. We'll put it on autocall.com like we do with the other webcasts. And the previous webcast, actually, for those of you who are a part of it on the Westel emergency communication system launch, has been published on there as well for replay. So if you think of a question afterwards, or if you think of just want to share some comments, feedbacks, or suggestions on other topics, feel free to email me at peter.ryan@jci.com, or Brian, as he indicated, you have his email, and we'd love to hear from you and to get your feedback. And also, before we close, I wanted to thank you guys. I know it's a really tough time with everything going on right now, and the work that you're doing is actually helping keep critical facilities like hospitals and manufacturing plants open for us. And I'm sure it's no joke to be going out to some of these facilities with the risks that you have. So I want to thank you for the work that you're doing, keeping the country moving, and also thank you for being part of the AutoCall family and for working with AutoCall Solutions. So please be careful, please stay safe and stay healthy, and we'll talk to you on the next session on next Friday. Thank you.